There we go. Zianda's hand is up. Zianda, are you ready?
Yes, ma'am, can you hear me?
Yes, I can.
Man, I'm not sure if it's correct, but yeah, let's try.
Okay, let's try it. Let's hear. We're married.
So first you're gonna say FG squared
G squared.
plus GH squared
Mm-hmm.
equals FH squared.
FH squared. Beautiful. My reason?
I don't like my reason.
Whose theorem is this?
No, I don't like my reason.
Hey, it's Pythagoras. See?
Just Pythagoras.
Yes, there we go.
Okay. And then you're gonna say brackets 32 bracket squared
Mm-hmm.
plus brackets 24 bracket squared
Mm-hmm.
equals 1.6 1600.
Oh, wait, let me do this. FH squared equals 1,600.
And then you're gonna put you're gonna square root it, and you're also gonna square root the FH.
Okay, square root. Therefore, FH is how much?
FH, and then the other one is 40.
40. Okay, now we have to work out JF. Do you agree?
Okay.
Zianda's like, okay, well, that was FH, right?
Yes, that is
Okay. So now we need this guy over here. Okay. Are you ready?
Oh, you said JF. I said FJ.
Yeah, it's fine. It doesn't matter.
Okay. It's gonna be 40 squared plus 104 squared equals FJ squared.
Oh, but look where it is. The hypotenuse is not FJ. Do you see that? The hypotenuse is 104 because it's the one opposite the 90 degrees. Do you see that?
Oh, remember, only said now.
Yay. Okay, let's do it together. So it's FJ squared plus 40 squared will be 104 squared. Now, how am I going to get rid of this 40 squared?
We're gonna square root. No, man, we're gonna move it over.
There we go. So FJ squared is left alone equals, what's 104 squared? Check for me.
10,816.
16, like that.
Yes.
Okay. Minus 40 squared, we know is 1,600, right?
Yes.
So then FJ will be equal to what's 10,816 minus 1,600?
Now, 9,216.
Okay, and then we square root both sides, right?
Yes.
Therefore, FJ is how much?
FJ equals to 96.
26. 96. Yay, see, Zianda, that wasn't that bad. Thank you so much for reminding me. Hey, I had actually forgotten. Okay, let's hear.
Why did we take it out of its square? Why did we write the actual number? Like, for example, 40 squared, we changed it to 1,600. Why did we do that? Instead of
because 104 minus 40 is not equal to 96. Okay. You have to first square it so that you can get 10,000, blah, blah, blah. Then minus 1,600. Then you can square root. So you cannot square root where there are two different terms. Can you see this minus? It's separating the terms. So
Okay.
you're not allowed to square root when there's two terms. You first simplify, then you square root, okay?
Okay, yes, ma'am. Thank you.
You're welcome. Welcome to all the new people. That was last lesson's question. Okay, guys. So don't worry if you were a little bit lost, like, what? I don't know what just happened. Welcome, welcome, guys. Now our lesson starts. I would be Miss Cat, and I'm with the lovely Miss Simone, who's already been helping you in the chat. She is absolutely fabulous. Oof. Guys, look how much she's glowing. It's fine. It's okay to glow. It's okay. Okay, so guys, welcome. Now the lesson is starting. I hope whoever did that question last week from the homework, last lesson, excuse me, did corrections as well. Okay, Zianda has so nicely helped us do corrections. Now let's start with today's lesson. So everyone who's new, and to remind our old Watobians, excuse me, if you want to ask or answer a question, press raise hand, the one in reactions. So if you see, you can press reactions and there will be a button that says raise hand. If you do that, then it will show myself and Miss Simone that your hand is up, and then I can ask your question or answer your question, okay? Okay, wait, ask my question, I'll ask your question. Guys, English is not my strong point. If you prefer to send a message in the chat, that's okay as well. I will see it, or Miss Simone, okay? Remember to keep the chat related to the lesson. You are not allowed to ask personal questions. You are not allowed to have chats that have nothing to do with the lesson, unless, of course, we're having our brain break, which you will see when we get there, okay? Remember to have a pen and paper in front of you so that you are doing the notes with us. It doesn't help to just watch. You need to actually do the sums with us. And if you can't hear us, you must press join audio, which is a little headphone that's usually at the bottom left or right of your screen, okay? Now, I asked you to take notes, but if you feel like I'm going too fast, you're welcome to take a screenshot instead. Now, if you're on your laptop, you press the Windows key and the button that says print screen. So it's PRTSC, and it will screenshot whatever is, it's a headphone, it's not a microphone. So yeah, it'll screenshot whatever's on your screen and you can go paste it on the Word document. Hi, Molly Bonkwe. Welcome, welcome. Okay, now let's get started with today's lesson. We are in geometry of two-dimensional shapes, and today we're going to be speaking about quadrilaterals, as in four-sided shapes, okay? Now, these are the four that we will be looking at today. We're looking at A, the first one, second one, third one, fourth one. And I want you guys to tell me what number A is. What do we call that shape by A? I should probably number them. What do we call that shape by A? A parallelogram. Okay, so here we are talking about a parallelogram. Beautiful. Okay, so all these properties that are listed under diagonals, angles, and sides for the first shape are applicant to a parallelogram. So let's look at the diagonals. Okay, diagonals of a parallelogram bisect each other. Oh, what does that mean? Does anyone know what that means when we say stuff bisect each other? Yes, Chi-Chi.
Does it mean that the both sides they're equal to each other, like they're supposed to equal to each other?
No, they're not equal to each other, but good try. Let's hear what Bokang has to say. Bokang?
Opposite angles are equal.
No, I'm asking about the diagonals, Bokang. What does it mean when we say they bisect each other? Okay, it's okay. Let's hear what. Oh, the hand is gone. Okay, guys. So, thank you, Buhle. I see in the chat. Thank you, Buhle. They cut each other in half. It said nothing about being equal, but it's talking about cutting each other in half. Let's look at the diagonal BD, right? Look here, on the diagonals, we have those two little marks over there. Okay, that means that BE is equal in length to ED. Okay, so if I tell you that this side of my diagonal is 4 centimeters. Let's say I say BE is 4 centimeters. How long will ED be? How long will ED be? Thank you. This will also be 4 centimeters. And how long would the whole diagonal be? The whole diagonal, which in this case is, thank you. So the whole entire diagonal, which is BD, will then be 8 centimeters, while the two halves are 4 centimeters. Now, I have a question. If BD is 8 centimeters, does that mean AC is also 8 centimeters? So BD is the yellow one. And we have AC over there. No. Okay, the answer is no. Remember, we said they bisect each other. We said nothing about being equal. So for instance, if BD is 8 centimeters, AC could be 3 and 3, which will be 6 centimeters. Okay. So remember, in a parallelogram, the diagonals are not equal. They bisect each other, so they cut each other in half, meaning 3 and 3 and 4 and 4, but they are not equal in length. Okay, that is a huge mistake we make. So they bisect each other, but they are not equal in length. Let me write it here. Not equal. Okay, now when we talk about angles, the opposite angles of a parallelogram are equal. So opposite angles. So angle A will be equal to the angle at C. So this whole angle over here will be equal to that whole angle over there. And similarly, the angle at D will be equal to the angle at B. So opposite angles are equal. What am I repeating, Chi-Chi? Chi-Chi, okay. Chi-Chi will let me know what I'm repeating. So the opposite angles of a parallelogram are equal. And then we talk about the sides, the opposite sides. So AD and BC are equal and parallel. Okay, so they're equal and parallel. So we have over here, AD is equal to BC, and additionally, AD is parallel to BC. Okay. No, I said the diagonals are not equal. Okay, Chi-Chi. The diagonals AD and BD and AC, they are not equal in length. So look at the table where I wrote it down. I wrote it under diagonals. They bisect each other, but they are not equal. That's all I was saying. Okay. Wow. Now we have a rhombus. I saw someone has already told us that the next shape is a rhombus. The difference between a parallelogram and rhombus is that the sides of a rhombus are equal. Okay, so over here we have a rhombus. There we go. Most of the properties are the same, most of them, but not all of them. Okay, so let's see what is the same here. Diagonals bisect other. Okay, we have another. Bisect each other, but we have an additional condition. Right angles at right angles. That means that this angle over here by the diagonal will be 90 degrees. Okay, so all the angles in the center of a rhombus are 90 degrees. And then the diagonals on top of that, they bisect the angles at the corner. So this side of D and this side of equal. This side of B and this side of B will be equal. And then A as well and C as well. So the diagonals cut the angles in half. That's what bisect. Okay, now when we look at angles, the opposite angles are equal, and we should know the interior angles add up to 360 degrees. If a triangle adds up to 180 degrees, then all the angles in a quadrilateral, you see it with all of them, adds up to 360 degrees. So, ma'am, E equals 90 degrees. Yes, boo. All the angles in the middle of a rhombus made by diagonals will be 90 degrees. Okay. And then with the sides, all the sides are equal and they are parallel to one another. So AD is equal to BC, which is equal to AB, which is equal to DC. And then on top of that, we have parallel sides. So AD is parallel to BC and AB is parallel to ADC. I don't know why I said A again, DC. Before I go on to a rectangle and square, are we all good with the properties of a parallelogram and a rhombus? Now is the time, now is a check-in point. How are we feeling about the properties? Thumbs up, thumbs down. For all of those who are new, when I say thumbs up, thumbs down, go to reactions and press thumbs up or thumbs down. Okay. Yes, Chichi?
Hi, ma'am.
Hello.
I just want to ask if they were to give us the, like, let's say for example a parallelogram, and then they gave us an equation to do, how would we solve it if like there were if there were numbers?
But there would be a lot of equations. Give me an example of what equation you're referring to.
Ma'am, I don't clearly have my math book at this moment, but then you can make a one up for your self, just for an example.
Ooh, Chichi, that's a very tall ask. There's a lot of equations that could be made, but we're going to solve them. Okay, we're not just learning this table. We have actual sums that are coming up.
Okay,
Do you
ma'am.
understand the properties so far, though?
Yes, ma'am.
Okay, that's the check-in, okay?
Okay,
Hang on
ma'am.
just a few minutes, and then we'll be doing examples of questions that we might get involving these shapes. Okay, last two, number C would be a what? What do we call the shape of number C? Number C, our third shape. A rectangle, thank you. Beautiful. Okay, so in number C, we have a rectangle. Most properties are similar to a parallelogram, but here is what stands out. First thing about a rectangle is the diagonals are equal in length. So remember, in a parallelogram, I emphasized that the diagonals are not equal. So in a rectangle, they are equal. And additionally, they still bisect each other. So that means AE is equal to BE, which is equal to ED, which is equal to EC. So all the diagonals are equal, which means all the halves of the diagonals are equal as well. Okay, the interior angles are all 90 degrees. Look at the corner. Do you see that? Those symbols are showing us that all the angles in a rectangle are what? 90 degrees. And then last but not least, the opposite sides of a rectangle are equal and parallel. That is the same as for a parallelogram. And then last but not least, I hear you guys say D is a square, and that would be correct. A square reminds us of a rhombus, but additionally, again, all the angles on the corners are 90 degrees, and all the diagonals are equal. There we go. Yes, Bokang, do you have a question?
I was going to answer, ma'am.
Oh, okay. All right. So those are the properties of rectangles and square. Now, take a screenshot of this and we are about to move on and do some practice questions and see what type of questions we would get relating to these shapes, okay? Obviously, I'm not going to say what shape is, okay, I might say that. We might say that, but that's like 1 mark for being nice, okay? We want to know if you can apply these properties, not if you can just cram them and know them and write them down in a list, okay? Cool. Now, let's start with this one. I want you guys to name each of the following shapes based on the description. Okay? Based on the description. So the first one says 4 sides are equal. So all the sides are equal and the opposite angles are equal. Not all angles, the opposite ones are equal. Think about it. Yes, Sibahle. Hi, Sibahle.
Yes, ma'am.
Yes, your hand is up.
Miss, can you hear me?
Yes, I can.
It's a rhombus and a square.
Oh, it's a rhombus I agree with, but I don't know if I agree with square, Sibahle.
Yes,
Remember,
ma'am.
with a square, all the angles are equal, not just the opposite ones.
A parallelogram.
No, now we are guessing, Sibahle. Remember, it says all the 4 sides are equal. Are all the 4 sides equal in a parallelogram?
No.
So it can't be a parallelogram. Do you see that?
Yes, miss.
So it's a rhombus. Okay. Okay, thank you, Sibahle. Okay, guys, we need to be more specific with our properties. It cannot be a rectangle because it says 4 sides are equal. Are the sides of a rectangle equal? No, they are not. Okay. Then it says opposite angles are equal. Not all angles are equal. Remember, in a square, all the angles are equal. So we need to be careful. Okay, Tsepang.
Ma'am, it's fine, ma'am.
Okay, remember to lower your hand, guys. Okay, the next hand I'm taking is answering or asking a question. Otherwise, please lower it. Otherwise, we are confusing each other. Okay, yes, Chichi. I see Chichi's hand just went up after I said that. Yes, Chichi.
Ma'am, I want to answer the second one.
Okay, what is the second one?
It's an equilateral triangle.
Thank you very much. Equilateral triangle. I see some people still saying A is a rectangle. It means we are not listening. A is not a rectangle, guys. 4 of the sides must be equal. All of the sides are equal. So in a rectangle, these 2 are equal, and then these 2 are equal. Not all 4 sides are the same length. Okay, only the opposite ones are equal. Okay, now let's go to C. C is a quadrilateral with opposite sides that are equal and all angles are 90 degrees. Oratile? Oratile? There we go. Oh, wait, you muted again. Yes, Oratile?
I would say maybe parallelogram.
Does a parallelogram have angles equal to 90? Oh, Oratile's connection is not so great right now. Okay. There we go, guys. I like you guys in the chat. It's a rectangle. Some of us need to go learn our properties. Remember, a rectangle is the one with opposite sides that are equal. So AD is equal to BC and AB is equal to DC. And it has 90 degrees angles. Okay. Number D, a quadrilateral with opposite sides parallel. Oh, opposite sides parallel. Yes, Chichi.
A parallelogram.
It's actually most of them, all of them. Don't you agree?
It is, ma'am.
Okay,
Most of
parallelogram,
them.
opposite sides are equal. Rhombus, opposite sides are equal. Rectangle, opposite sides are equal. Square, opposite sides are equal. So this is parallel, excuse me, not equal.
Parallelogram.
So it's all of them. Do you see?
Yes, ma'am.
All of the above. I hope we can all see why it's all of the above. Okay, now we are on number E. Let's check what number E says. Number E says quadrilateral with adjacent sides equal and opposite angles equal. So adjacent, the ones next to each other are equal and the opposite angles are equal. Not all angles, only the opposite ones are equal. Yes, Ndalo?
Is it a rhombus?
Yes, it is. Beautiful. That was brilliant. Okay. Okay, let's see. A triangle with two equal sides. What do we think? Farid?
Ma'am, is it an isosceles triangle?
Yes, it is. Beautiful. Isosceles triangle. Okay, and it says a triangle with three different angles. Let's hear. Do be sang. Do be sang. Do be shang. Excuse me.
Excuse me.
Ma'am, a scalene triangle.
Mhm. Okay, beautiful, guys. So it seems some of us might still have to go revise our properties, but that's okay. That's okay. We just need to work a little bit harder on remembering our properties, okay? Now, let's do a proper question. PQRS is a rhombus with S equal to 35 degrees. Calculate the size of all other interior angles. So we want the size of S1. Sorry. S1, Q1, Q2, P, and R. That's what we want. Any ideas for any of these? First, let's start with what do we know about a rhombus? Oh, Mikhail, S1 will be 35. Why do you say that? What's your reason? Remember, we have statements and reasons. So you're saying S1 is also 35 degrees. What's your reason, Mikhail? Remember, S1 is next to S2. Not necessarily. Not necessarily. Anyone know what our reasons are? Oh, we need to work our reasons on our reasons. Nope, it cannot be alternate. We're doing S2. Remember, S2 is next to S1 is next to S2. So it can't be alternate angles because alternate angles are all the way down there. Okay, so this is my reason. Nope, it's none of those. Okay. It's because the diagonals of a rhombus bisect the angles. This goes back to knowing our properties, guys. The diagonals of a rhombus bisect our angles. It was part of our properties. Look at there. Look at there. Okay, the diagonals bisect the vertex angles. Can you see that? Diagonals bisect the vertex angles. So the diagonal of a rhombus bisects the angles at the corners, at the vertex. Okay, now we have S1. What about Q1, Q2, P, and R? I like that we're talking about parallel lines because that means we are paying attention to something. There we go. I've filled in your parallel lines for you. Any other angle that you guys can identify? It's awfully quiet. Come on, guys. We're not going to have a brain break if we don't do this. I have so many nice, exciting. I know you guys can do it. You forgot the triangle. Ew. What triangle? Yes, Luyanda, but we're looking for the angles. Oh, I see where Luyanda's going with this. Yes. Q2 equals 35. Thank you, Zianda. What's my reason? Zianda says Q2 equals 35. Q2 equals 35. Yay! S1 equals Q2. Alternate angles, beautiful, Sia. Alt angles, because PS is parallel to QR. Wonderful. So we have S1 and Q2. Or Zianda's answer, which is diagonals, bisect the angles. Yes, you can, Mikhail, because we know that the opposite sides are parallel. So we can use that. You can even use the rules of a triangle. Remember, you see we have two triangles here. It's possible to just use the triangles as well. Okay, let's see. Q2 equals 35. Yes. What about Q1, guys? What's Q1? It's 35. What's my reason? What's my reason? Did a hand go up? Hello, Zoom user.
Ma'am, it will be diagonals of a rhombus dissect angles.
Thank you very much. That was beautiful. Diagonals of rhombus bisect angles. Thank you. Okay, now we're left with angle P and angle R. It's here. Angle P and angle R. Don't forget your fun rules, guys. That's a very nice clue for you guys. Don't forget the fun rules. Yes, Raven? Was Raven the one who just spoke to me now? Yes. Okay. Yes, Chichi, your parallel line rules. Oh, where am I writing with the highlighter? Corresponding angles, co-interior angles, and alternate angles. Those ones. Remember your parallel line rules, alternate angles. Okay, Butle says angle R is 35. Okay, Butle, what do you say? Oh, Zianda did something very, very awesome there. Zianda says R plus 35 is 180 because it's the sum of interior angles of a triangle. Do we see that we have this triangle over here? That was terrible highlighting. So I'm just going to forget about it and forget that it happened. There. There we go. So that is a triangle and we have two angles. So we can use the sum of the triangles to find R. If you do this, you'll find that R is equal to 180 minus 70. Therefore, R is 110. That was beautiful, Zianda. Now we're left with P, guys. We're left with our last angle. We're left with P. Anyone know how long P is? Anyone? Zianda says P is 110. That was given. No, it wasn't given. It is 110, but it's not given. What property can we use of a rhombus? Of any parallelogram, actually. Of any quadrilateral, excuse me. The ones that we've read. P is 110, but what's my reason? Umulimo? Hi, Umulimo.
Hello, ma'am.
Hello.
Ma'am, the opposites of a rhombus are the same, ma'am. The opposite
There we
angles of a
go.
rhombus.
Opposite angles of a rhombus are equal. Beautiful, guys. Ooh, that was gorgeous and beautiful. Now is question time. Thumbs up, thumbs down. How are we feeling about doing sums with the properties of quads? How are we feeling? Yes, yeah, I see what you just did. No, Litando, some fun rules are going to take quite a bit, but we did do them a few lessons ago. So you can go to the website and watch the videos on parallel lines. It was a section just before this, okay? It was a section just before this. Yes, we're getting there. So we need to do more, guys. We need to do more. Okay. Yeah, but we need to upgrade, guys. We can't always be grade 8, grade 8. We are good. We are old now. Okay, I want to do, never mind. Let's go back to this one. We're going to have a brain break at the end of the lesson. Okay. So we have a parallelogram. Okay, what do we know about parallelograms? What do we know about parallelograms? This is how you should solve these, guys. So we know that the sides are parallel, right? So that side's parallel to that one, and that side is parallel to that one. Boom, boom. Wonderful. Okay, interior angles add up to 360 degrees. That would be correct. What else do we know? Yes, Sibahle. Hi, Sibahle.
Miss, they bisect each other.
The diagonals bisect each other. That's correct. So that side is equal to that side. That's equal to that. Okay.
And
oh, sorry, Sibahle. Sorry. I know you were still. I didn't know you were still talking. You can unmute.
Miss, and the sides are not equal.
Okay, the opposite sides are equal, but not all four of them. So this side is opposite is equal to that one, and that one is equal to that one. Okay, is that all? Is that all we know? Interior angles are equal to. Okay, I see something interesting there, but I have a feeling Sia meant D1, not B1. D1. So Sia says D1 is 75 degrees, right? And my reason is what? Sia said it. Alternate angles, because AD is parallel to BC. So we know this one is also 75 degrees. Remember, we want Y. Now Y goes all the way from there to there. Oh, that was terrible. Y goes all the way from there to there. Okay, so now we have that 75 degrees. What else can we do from here? Think of all the rules you know, guys. Parallel lines, triangles, everything. That was a big clue. Parallel lines, triangles. Simone is laughing because she's like, it's the clue, guys. It's the clue. Look carefully. Yes, Umulema?
Ma'am, A1 is equal to A1 is equal to 57 because of the interior angles of a triangle.
Yes, Umulema. So A1 is equal to 180 minus 75 minus 48. And that gives you how much?
57.
57. And my reason is sum of interior angles of a triangle. So now we have A, guys, 57. We're almost there. We're almost there. Do we see that, guys? We are almost there. Bokang, do you know what we have to do next?
Yes, ma'am.
Okay, let's hear.
We will say D1
A1
plus 48
plus 48
plus A1.
plus A1. Is that what you said?
Yes, ma'am.
I already added A1. Do you see that?
Oh, I can see my mistake, ma'am.
Okay.
This
Okay.
one
But Bokang, I know you know this, right? Look carefully. 57 and Y. They are angles.
So, ma'am, let's try this one.
Okay.
75 plus 57
Okay. 25 plus 57
plus 48. Plus Y.
plus Y. Okay.
Plus 180 degrees.
What's your reason?
I have problem with this one, ma'am.
Bokang, you're cheating me. Bokang, do you see that 57 and Y are on a straight line?
Yes, ma'am.
What do angles on a straight line add up to?
180 degrees.
So do you agree with me when I say 57 plus that angle, Y will be equal to 180 degrees?
Yes, ma'am.
There we go. And your reason will be adjacent
Adjacent
angles
angle.
on a straight line. So then how much is Y?
Y is equal, wait a minute. Y is equals to 48.
What's 180 minus 57?
180 minus 57 is equals to 123.
There we go. There you go, Bokang. Hey, guys. Do you see that, guys? Ma'am, would the reason be supplementary adjacent angles work? Yes, it would. Yes, it would. Okay. Or, guys, if you didn't want to go through all of this, you could have said Y is equal to 75 plus 48. And that's your exterior angle of triangle. Okay. Are we all feeling good about that one? And thumbs up, thumbs down. I almost said hands up. Hands up, hands down. I'm kidding. Thumbs up, thumbs down. Are we feeling good about that one? We need to know all the geometry rules to do these things. That's a lot of rules to remember. Yes, Tando? Tando? Tando, you can unmute.
Hello.
Yes.
Can you please explain again, ma'am?
Which part, Tando?
From 57 plus y equals 180 degrees.
Okay, Tando, can you see the line AD? This line.
Yes, ma'am.
That's a straight line, right?
Yes, ma'am.
And what do we know about angles that are next to each other on a straight line? Tando. Okay, we have lost Tando. I think he's disconnected. No, Chichi, there isn't an easy way. You just have to spend time with the sketch. That's what I tell my learners. Spend time with the sketch. You get a test, and it's like 30 minutes with one question, and all the kids think, whoa, I gotta finish this question quickly. And then they want to rush through it. You just have to spend time. Excuse me, when you see a shape, as soon as they say, this is a rectangle, you need to write the properties. What do I know about rectangles? The angles are 90, the diagonals are equal, the opposite sides are equal and parallel. And then you look, you spend time with it. You look where y is, and then you try and find other angles to help you find y. But there is no easier way. First, you need to know the rules, because I feel like we're forgetting. Okay, first we need our rules, to know them and to know them well, and then we can apply. Okay, guys, I think we deserve a brain break, which might not be a brain break, but you know, it is what it is. Yes, yeah, you have to take your time with these sketches, okay? Okay, how many squares are in this picture? How many squares? We're about to throw hands again because every time I counted over and over, I got a different number. And I was like, I don't know what's going on. I don't know what's going on here. 4, 5, 10. You always at 10. And Aruna, Farid, 9, 5, 11, 5, 4. Oh. Wow, guys. These answers are so wild. We're up to 11. Interesting. 12. Woo. I hope someone's counting because I'm not. 16. Oh my goodness. Wow. Whoever said 16 must show us how you got to 16. I am very curious. Okay. Chi-Chi, it's a brain break. Give your brain a break. 10, 5. Okay, let's start counting. Let's start counting. Okay, I'm going to start with the small babies. 1, 2, 3, 4. Okay. I'm going to do a tally again because I suck at counting these things. So 1, 2, 3, and 4. Those are the small babies. Okay. Now I'm going to the medium babies. This one. 1, 2, 3, 4. Okay. 1, 2, 3, 4. Okay. Now I'm going to count the big baby. The big one. No, those are not rectangles. They're definitely squares. 1. Okay. Then there's one in the middle. There. And another one over there. That's 2 of them. Right? So 1, 2. Okay. Now I'm going back. So far how much do I have? 5, 10, 11. I have 11 so far.
I was
Okay.
also on 11, and that was all that I saw. I can't see any of it.
I can't visualize anymore because I'm trying to look here. Nope, the rest are rectangles. Yep, I'm going with 11, guys. I'm going with 11. We counted it, Oral Dean. Trust me, I counted the big one. Yep, this one. That was the big baby, this one. So I definitely counted it. Malibong's like, I totally knew that. There are 11 squares. Yes, brain break means gym your brains. Do you want to dance during a brain break? Now that is a brain break. How many squares are in this diagram, guys? What a way to end off with a bang. Honestly, I give up. Who was that? Okay, we have the one big one. Okay, big baby. Then we have this one, this one, this one, this one. And then we have the one that's rotated like that, and the one that's rotated like this, and the one that's rotated like that, and the one that's rotated like this. Woo! I want you guys to take a screenshot, and in the next lesson, you're going to tell me how many squares are in this thing.